Bonjour, mesdames, messieurs. J'ai passé quelques temps à Montpellier. That's a long time ago. As a medical student, I went to Montpellier, so I have very good memories to France. And it's a great honor and pleasure to speak to you. So thank you very much for this invitation to present our work on CDISC ODM tools to this audience here. So I would like to talk about our portal of medical data models in CDISC ODM format, and in particular about our tool ODMConverter. So if you have any questions or if you can't hear me, please feel free to interrupt me. And otherwise, then at the end we can collect questions and discuss about it. So first I would like to start with some very short remarks about my institution here, the Institute of Medical Informatics at the University of Münster in Germany. Then a presentation of this portal of medical data models in ODM format, followed by a detailed description of this ODMConverter tool and a discussion about potential next steps and collaborations. So perhaps about my institutions. Who am I and what are we doing here? So here Münster is a typical German university hospital. Compared to APHB, it is a tiny hospital, but we have about 60,000 inpatients per year, 500,000 outpatients per year, and overall 1,450 beds and 30 clinics. And here my institute, so we belong to the medical faculty, Institute of Medical Informatics. Our research focus is informatics for personalized medicine, and we have two work groups in this institute, one on health informatics and one on biomedical informatics. The key research topic we are following here is the single source paradigm. So currently, as you well know, we have routine care in hospitals, and we have electronic health records, EHRs, on one side, and on the other side, we have medical research, and we have electronic data capture systems. And currently there is this red wall. So basically the data management on the clinical side and on the research side is almost completely separated or duplicated. And in PowerPoint, life is so easy. You just click the button and the wall disappears. So the idea of single source is to enrich EHR systems and make them available both as a data source for routine care and medical research. So we are part, you can see it in the upper left side, we are part of the EHR4CR consortium. You probably know this, have heard of this project because Paris APHB is also involved, both on the clinical side, so Eric Sapletal, and from the methodological side for the terminology, Crystal Daniel. So this is a large international project, European project, and it has 4 use cases. So we would like to develop new software first to optimize clinical protocol designs. So the goal here is to be able to send queries to an EHR system to answer questions like how many diabetes patients do you have in a certain age range with a certain set of comorbidities and lab values. So these are software tools to improve the design of a trial. The second use case is patient recruitment, enhanced patient recruitment. So this is a software platform where the research team at each hospital site is supported by a software tool that produces screening lists of potential trial subjects and provides access to more detailed clinical data. Of course, all these data access need to be compliant to existing data protection standards. The third scenario is about optimized clinical trial data collection. So it is about what kind of data elements from EHR systems are important for research, and are there ways to automatically transfer this data into EDC systems. And finally, it's about serious adverse event reporting, also taking advantage of available EHR data. So it's a large consortium, more than 30 members, large budget. So a huge project, and it's now this is a project now running for 4 years, and we will have a year 5. Other research we're doing here is about how to build clinical registries with EHR integration. So we have built a system, it's called X4T, Exchange for Trials. Basically, if you look here to the left side, you see the EHR database of our hospital, and there's a way to extract certain data from the routine system and have some additional software component that then ultimately transfers it into the EDC system. That's another example of work here. We are interested in software to collect patient-reported outcomes. So we have an iPad application here in the field of dermatology, and this iPad is actually connected to our EHR system. In addition to that, personalized medicine is, of course, also about genomic data. So we are very active in the field of leukemia research and leukemia-related diseases. So for instance, we're doing here genomic analysis, next-generation sequencing for MDS patients, and we develop software to generate clinical reports from next-generation sequencing data so you can't read this here, but this is about you're sequencing a patient, and then some data processing occurs, and at the end you generate a clinical report that is presented to the physician. So ultimately it is integrated into the EHR system. So now let's come to the topic of today's presentation, CDISC ODM tools with open access. We have a project, it's called Portal of Medical Data Models, MDM. And the background here is, if you think about the current information system landscape in healthcare. So currently EHRs are a heavy workload for our physicians. Between 25 and 40% of daily work is dedicated to EHR-related work. And unfortunately, currently we have very custom proprietary data models for each hospital. And we have a huge amount of documentation forms. A typical hospital has more than 1,000 different documentation forms. And if you look into the research documentation, that's where you are very familiar with EDC documentation. You are well aware that the number of CRFs per study is large and increasing. There's some paper, I think from Getz, where he calculated approximately, on average, 180 pages per patient need to be filled in. So that's a huge amount of documentation work and a large challenge for data management. And the interesting point is that there's a large overlap with routine documentation, because I would say a large proportion of these 180 pages is dedicated to exclude, to document all data that might be relevant in the context of adverse events. And basically that's the same what you're doing in the hospital. You are documenting everything that is interesting about a patient, and to document that you did not overlook any important medical finding. Now, medical data models, as you can see, are a large-scale problem because the documentation is disease-specific. For each disease, different medical facts are relevant. So, but ICD-10 has more than 13,000 diagnoses. The vocabulary in medicine is very complex. The systematic nomenclature of medicine has approximately 300,000 terms without synonyms. And of course, the documentation in a hospital is language specific. So in Paris, you will have French documentation. Here we have German documentation. Over the world, so you have 200 different languages. So that's why documentation is really challenging. And it is also EHR specific. And currently, in Europe, we still have a very large variety of EHR software products. There are more than 800 different products for about 10,000 hospitals available. And last, these medical data models are trial-specific. In clinicaltrials.gov, we have more than 150,000 trials, and typically you have more than 1,000 data items per trial. So this is very obvious, given your experience and background, that medical data models in trials are complex and heterogeneous. So you see here these different power plugs. When you're traveling around Europe and the world, you're familiar with this problem, and it's a very easy problem. You only, for electricity, you only need to connect 2 pins. But here comes another feature of medical data models. Most of them are secret. So, and that's what makes data processing in the hospital and in clinical trials really very, very complicated. And actually, that's something that can be changed and that should be changed. So it's clear that the medical data itself, the patient data, is sensitive and secret. But empty forms should say be top secret? Well, I don't think so. So because what we are doing in particular in trial documentation is reinventing the wheel again and again. And so the idea of the system is, to have open medical data models to help to share best practice and therefore to improve the design of data models. It is, of course, also about the accelerated development of new documentation forms. It's about standardizing forms, and it's also about better integration of EHR, so hospital routine documentation, and EDC integration. And here semantic annotation plays a key role. When you talk to many people in the hospital, my experience is documentation is seen as something very bureaucratic, but you are probably well familiar that real good documentation is an art. You have to collect all medically relevant information in an understandable way and design it in a way that the time you need to fill in the forms is as small as possible. So making good forms is really very, very complicated, and it's an art. And ultimately, it's about more efficient clinical trials. So what we have so far, here you see the internet address, medicaldatamodels.org. This is, to my knowledge, the largest public portal for medical forms worldwide. So currently, we have approximately 5,400 forms available with 180,000 data elements. It's a focus on oncology. So, for instance, in pediatric oncology, we have a lot of forms from different trials. You might know Ewing sarcoma, also here MDS sarcoma, or it's also about COPSET and S, so this is about brain tumors. Then also by our research activities here, we have forms from several different leukemia trials. The National Cancer Institute started an initiative to post CRFs on the internet. So here we also have quite a few forms. And what we are doing, we are also adding semantic annotations to these forms, in particular UMLS, SNOMED code, but also where available MEDRA or Loing codes. And we also provide, and I will demo it to you, a web-based editor to generate and update ODM forms. So this is a prototype. You can download forms, CRFs in various technical formats. So primary format is CDISC ODM, but also in PDF, Excel, SPSS format. And in addition to that, it is also a discussion forum for forms. So the idea is when you have a consortium where 20 or 30 different partners need to agree on a certain set of CRFs, the coordinating site is posting it, and then it is distributing the link to this form set to other colleagues, and then they can online comment on the forms. They can say, here, this item needs to be changed, the item is missing, the code list is wrong, things like that. And then the coordinating center will publish a next version of the forms until a consensus is reached. So the system has full version control, and in particular, it supports multiple languages. So we have I will show it to you. We have one form that is available in 26 languages. So that's the homepage of the system. So you can you see my pointer here? Yes. Okay. So here in this part you have the best rated form. So all users can use. So you know it from Amazon. You can give this is 1, 2, 3, 4, or 5 stars. The users can say, this is a very nice form. So this is a list of best rated forms. Here, this is some summary statistics. So here it says current version 4,000 forms, overall 4,500. Here you can see the most frequent keywords. These keywords we are using mesh keywords. And here, so you can see currently the focus is here on cancer, also something diabetes mellitus, and here, but also here hospital information systems. Here you have a search function. You can enter just free text, and then you will receive a list of matching forms. You can select from keywords, and you can manage your own forms in the system. So here, this, as an example, would be the WHO 5 Wellbeing Index. That is a quality of life form developed by the psychiatrist here somewhere in Denmark. And here, that's an example of this comment. So here, you might know Wojciech User from the US, here where I said, nice to see the Czech version of some form. And here, this is a screenshot of the editor. So here you have the item name, then you have the translation in each language. Here you have some codes, the data types, and an overview of the code lists. So if that's okay with you, then I would do a quick live demo of the systems. Or do you have any question at this point about the system? So now I'm live here with the web browser and the system. So I just open now where is it? It disappeared. So let's go and search it. Search function. So I enter WHO. And here I get the first hit is here the WHO Wellbeing Index. So, okay, so you know these 5 questions about your overall quality of life. And here you can select different languages. So now let's go to French. I think actually I sometimes use the WHO 5 personally. It's very nice. So every 2 weeks you need to fill it in, and then it will calculate a score between 0 and 100, and it will tell you whether your quality of life is okay or not. So that is the overview. There's a detailed view here. And so you have these 5 items here. So, je me suis senti bien et de bonne humeur. And here you have the code list with the different values. And so here you have the next question. So here you can see these 5 questions of the WHO 5. You can now download it in different formats. So the primary format is CDISC ODM. I assume that almost every one of you already has seen an ODM file. I hope you probably, let me see if I can zoom it. Can you read it a little bit now? Okay, so here you can see this is the CDISC form, study name, and then here you have study event def. The key is here the form def, so the form name here, and then you have the first item group, so it's always about over the last 2 weeks. And here you can see the translated text is available in many different languages. Then you come to the item ref section, and here the item definition. So the first item is an integer item. It's called lately cheerful with this ID. Then again, here you have the translation in the different languages. And you see it's associated with a certain code list number 1. And here we use the alias text to provide semantic annotation. So it says here in UMLS, the Unified Medical Language System, this item has this code. And if you go down here I'm just going now down to the code list section. So where does it start? Code list, code list, code list. Okay, so here you see the code list. And here you have here coded value 5 has this list of different translation and so forth. So it's pretty straightforward CDISC ODM file, but you also can download it in other formats here like PDF. So now you have the PDF version of it. and you also can download it. If you're working with SPSS, you can download it as an SPSS command file. So you can generate an SPSS file directly from this form here. And last but not least, you can also create an R file. I don't know how many people of you are familiar with R, but I hope many will understand also this syntax here. So here a data frame is generated corresponding to this form, including all the var labels and the different factor levels. And finally, we always try to get rid of Excel, but probably that will never work. So we also provide here a download as Excel format. So you can open it here. And I just zoom a little bit. So you have in this part here, you have some general information about this form, and here to have the different items in here in English and in German, and including also the code lists. So you can really download it in various technical formats depending how you want to use it. And if you say now, I'm the author of this form and I would like to update it, to generate a new version, then you just click here, create a new version, and then you say, I would like to use the web-based editor. And then the same form appears in here. So you can see this is the WHO Wellbeing Index, the first item group over the last 2 weeks. And here now we are in Paris, so let's switch to French. So you have the item names are still English, but the text is now in French, and you can select an item here. And then you could here update this text. You can see this, what is called a concept code here. This can be, there's an online tool to help you to find the right code. So here it says, if you say select concept code, then a search function will come up, and that will tell you that Lately Cheerful has this code. So for instance, if this item would be pressed, then you say here select concept code, and then you could select here the code for depressed mood. You also can look into the details of this code list. So you could also assign concept codes or update the code list if you want. When you are finished with your updates, then you say you can either download it for your own use and use it in any other system, or you can say upload to portal, and that will create a new version in the system. So that is basically what can be done here. You can just a very short demo here of this keyword function. So for instance, if you say I would like to see cancer-related forms, then you get here a long list, and you just can choose any of them. Or you can go here directly to keywords and could say, for instance, I'm interested in forms related to electronic health records. Then you say here EHR, we have here 96 forms available. You download it here, and then you can just go through and choose any of it. What might be of interest to you that we have a collaboration with CDISC in the context of EHR for CR, and so we also try to work with CDISC related forms. So you probably all know CDISC. So you can say what kind of CDISC forms are available here. You just enter CDISC, and then you have this list of 22 forms. And for instance, you can see here the concomitant medication form. Or I think, which is very useful, this lab result assessment form. you probably know that the FDA has released an SDTM, a set of more than 600 lab codes. These lab codes are actually available here. So here you can see we have a code list of the 600 plus most common lab values. And I think what is really interesting about this material is that if you look into the ODM file, let's choose any example, for instance, creatinine. Okay, then in SDTM, FDA has assigned a certain NCI thesaurus code here to creatinine, and we also added the UMLS code here. UMLS is interesting because you also then have direct mappings to SNOMED and also to MEDRA. So that would be a short demo of this portal. Any questions here at this point?
So I'm just to make sure.
Can you speak up, please?
Sorry, just to make sure, the portal is totally free for every researcher, or is it private or needs some subscription?
It is open access. That also means the content in here must be content that can be released to the public. Yes, it's an open access. There are, for some instruments, there are from the instrument itself there are restrictions. For instance, the hospital anxiety and depression scale is something that you can download on the internet, but when you use it, you have to pay to the owner of this form some license fee. So the material in here. There's also, it is open access. You can read it, you can download it, but if you use there are few forms where there are some restrictions. For instance, the EURTC, to my knowledge, provides some forms, but only without fee to academic researchers. So if you are running a commercial trial, then you have to pay the fee to the EURTC. But the general idea here of the system is to have a public portal. And we prefer, wherever possible, free materials that can be used by any researcher. So now the tool ODMConverter. So you're quite familiar that there are different stakeholders in clinical research, and they use different IT tools. So when you work with medical personnel, and they typically use standard office tools like Microsoft Word or Excel. And then the next step, when the data manager are setting up their systems, they work with EDC systems. So in the commercial setting, you're using Medidata Rave. You might use Secure Trial. There are plenty of them. You name them. And when the database is closed, when the data is collected, then the statisticians come in. And they use different statistical software, typically in a trial setting, SAS, or in other settings, SPSS. Now, you might remember I told you that CRFs are quite complex. On average, 180 pages per trial. That corresponds to maybe around 1,000 to 2,000 data items. And of course, if you work already with the metadata, with the item names, there is a really high cost and a source for error due to manual metadata conversion. So typically you start with a Word CRF, then you build an eCRF in your EDC system, and then you get a SAS data set. So the idea of ODMConverter is to provide automated metadata transformation between several technical formats. So currently it has a strong emphasis on CDISC ODM. So it supports CDISC ODM, Excel, R, and in the clinical area is the CDA, the Clinical Document Architecture format. That is a public tool. It's available in the CRUN repository. You can download it on Windows or on Linux and just use it. And there's a paper here published in PLOS ONE that describes the details. So just an example, when you start with a certain Excel spreadsheet in a certain template, that's a screenshot from the paper. So here in this example, you would have a certain sponsor in a certain study, and here we would have the first item group called general information, and the first item would be Boolean item, willingness to participate in a clinical trial, patient, let us say, a certain age, date of birth, and so forth. So that would be an Excel template where you collect basic information about a form. And then you would run on your computer the command office to ODM that would take this file, if it's called ODM test XLSX, and then you would the output would be an ODM file. So that's a section of this code here. So you can see metadata version, item group, info, and here you can see here the willingness in Boolean and age, date of birth, and so forth, corresponding to what you have seen on the previous slide here. Okay? And then the next step would be, so now we are in EDC format, and now when you want to transfer this data structure into your statistical system, so here we use R. There's a command called ODM to R that takes this ODM file as input and then creates an R data frame out of it. And it also tries to transfer the related, here the var labels, and translates the semantic codes. It also has attributes about the sponsor and the condition of the trial and all the var labels. So that should be pretty straightforward. And there are also further tools available. So it works in both directions. So there's a tool called Office to ODM that generates ODM, and ODM to Office does the translation in the other direction. There's this tool ODM to R that generates this R data frame, and R to ODM does the reverse. And in addition to that, we also have a converter for the clinical document architecture, again, ODM to CDA and CDA to M. You're probably familiar with some of the R tools. There's a whole universe of tools, and there are various converters available how you directly can convert R data frames into SPSS files or into SAS data sets. So that can be directly used. I have to emphasize at this point, this is only about metadata conversion. A possible next step would also include a functionality to convert the data section. So at this point, when you have your EDC CDISC ODM file, at this point it does only convert the item depth, but not the clinical part section. On the other hand, to my knowledge, some of the statistical programs already now are capable to directly import CDISC ODM. So that is what I wanted to present to you, and for discussion. So you are the French CDISC user group. I think what, from my perspective, would be very interesting. It would be great if you, members of your group, could test this portal. So download forms, upload forms, test the form rating and discussion functions. An interesting question to us is, what content should be added? We have around 5,000 forms, and this is just the tip of the iceberg. So medicine is so rich, so semantically so rich, we probably could have 100,000 forms. But key question is, what content is relevant to the user of this portal? And of course, we would be very interested to receive ODM forms from France, from your research, both to enhance the content. Also, it would be great to have maybe French translations of existing forms or natively French forms in the system. Then, of course, it would be great if you would test this converting tools. Maybe if you have R developers, if you also would contribute to the further software development of this free tool. We would be interested because, to our knowledge, many EDC systems are not fully CDISC ODM compliant. So they understand a certain ODM dialect, but not the full scale of CDISC ODM. So it would be very interesting to see what happens if you download ODM forms and import it into your local EDC systems. Is this working, or what kind of technical issues come up? We would like to spread this idea of exchange of metadata in clinical research. So it would be great if you could inform the CDISC community about these tools. The overall idea is to set up, say, a Wikipedia of trial forms, also a large set of free tools to foster clinical research, to make it more efficient and effective. And of course, it would be attractive to develop further ODM functions for R. Thank you for your attention.